Alrighty, 6.1 properties of exponents. Now, I don't necessarily expect you to copy all of this down, but there are some good pieces here. So in words, it says for any non-zero number a to the 0 equals 1. The power 0 to the 0 is undefined, right? So you can't have 0 to the 0. With numbers, that would be 4 to the 0 is 1. Algebra would be a to the 0 is 1, where a does not equal 0. The good thing to know here is 4 to the 0 is 1, or a to the 0 is 1, all right? Anything that's not 0 to the power of 0 is 1. Negative exponents. For any integer n and any non-zero number a to the negative n, let me see if I can draw that a little bit better, a to the negative n is the reciprocal of a to the n. Now, what does that mean? If we had 4 to the negative 2, that would be 1 over 4 to the 2, or 4 squared. For algebra, that would be a to the negative n would be equal to 1 over a to the n. And again, we can't have a being 0. The important things there are that we need to know this. I guess I need an equal sign there. And that. All right. Example 1, we're supposed to evaluate. 11 to the 0 is 1. Right? Any number to the 0 is 1. All right. Example 2, 4 to the negative 3. Well, because it's to the negative 3, we could flip that over and we could say, well, this is 1 over 4 to the third. 4 to the third is 64, so this will be 1 over 64. All right, looking more. Well, that doesn't look right. Huh. Well, let's scroll down here. Product of powers property. Ooh, power of product properties. Well, it skipped over some rules here. All right, here. We'll go right here and we'll write these rules down. The product of powers. All right, product means to multiply, and then powers means we have exponents. If we have something like 4 to the 6th times 4 to the 5th, that would be the same thing as 4 to the 5 plus 6, which is 4 to the 11th. Okay. In algebra terms, we would say a to the m times a to the n would be a to the m plus n. All right. That's what we may need to make sure we know. Okay. If you have two things next to each other that have the same base, then you can add their exponents, right? If they're multiplying, you add the exponents. Next up, we have quotient of powers. This one talks about division, whereas the other one was multiplication. If we have something like 4 to the 6th over, we'll say 4 to the 2nd, that would be 4 to the 6th minus 2, which is 4 to the 4th. Using algebra, we could say, well, if we have a to the m over a to the n, that would be a to the m minus n. Okay. And power of a power property. Use another color for that. Power of power. Power. This would be something like if we had 4 to the 6th squared, that would be equal to 4 to the 12th. You would multiply those. Okay, here, let me write that step in there. We'd say 6 times 2, and then we'd say 4 to the 12th. Using algebra, we would say if we had something like a to the m to the n, that would be a to the m times n. All right, we need to make sure that we have these rules here. All right, moving back, and I think we're supposed to be on example 3 now. Wherever, oh, there it is, okay. Example 3, this is supposed to be 9 squared times 9 to the 5th. Well, those are the same base. They're both the number 9. We can add their exponents. This will be 9 to the 7th, which is some huge number, but I'm just going to leave it as 9 to the 7th. Example 4. This is 5 to the 6th with parentheses around it squared over 5 to the 3rd. The parentheses up top should tell us, oh, we have to multiply here. So this is going to be 5 to the 12th over 5 to the 3rd. And then we have 5 to the 12 minus 3. We can subtract that bottom piece, which would be 5 to the 9th, which again would be some huge number, and I'm just going to leave it as 5 to the 9th. Alrighty, next up, power of a product. So this here, using numbers, we'd say 3 times 2 to the 5th would be 3 to the 5th times 2 to the 5th, right? It's almost like distributing, right? Distributing, we normally think about whenever we have something like 5 times, I don't know, 6 plus x, and we distribute the 5, right? This is kind of like distributing. It's the exponent version of distributing. In algebra, if we have ab to the m, that would be equal to a to the m times b to the m. Right, this rule also works for division, for quotients. If we have 3 halves to the 5th, that would be 3 to the 5th over 2 to the 5th. In algebra, we could have a over b to the m would be equal to the a to the m over b to the m. And of course, b can't be 0. All right, example number 5. This one is 4x to the 4th with parentheses. Well, we kind of distribute that exponent there. We'd have 4 to the 4th times x to the 4th. 4 to the 4th is 256, so this would be 256 x to the 4th. Example number 6, this is c over 2 all to the 5th. This would be equal to c to the 5th over 2 to the 5th. 2 to the 5th is 32, and c to the 5th stays the same. Example number 7, this is 5 to the 0 times 2 to the negative 3. Well, 5 to the 0 is 1, so we could turn that into a 1 times 2 to the negative 3. Well, 1 times anything is just whatever the anything was, so this is just the same thing as 2 to the negative 3, right? Notice there, we had 5 to the 0, and it just goes away, all right? On homework and stuff, if you have something to the 0, it can just go away whenever it's in a fraction like this, right? 2 to the negative 3rd would be 1 over 2 to the 3rd, and 2 to the 3rd is 8, so this would be 1 over 8. Example number 8. This is 8 to the 5th, or 8 to the 5th, times 8 to the 6th over 8 to the 7th. Well, the numerator could turn into 8 to the 5 plus 6, and then we still have our denominator. This would be 8 to the 11 over 8 to the 7, which would be equal to 8 to the 11 minus 7, which is 8 to the 4th. And I'm just going to leave it as that. All right, the last 2 examples, we've already done ones like this. If you'd like to do them on your own, you can. But this is 2y to the 6th and b over 5 to the 3rd, right? Your answers should be, if you were to work these out on your own, would be 64 y to the 6th and b cubed over 125. Alrighty, that is 6.1.